Greetings to all. This is Vaishnavi, Assistant Professor, IT Department from SNS College of Engineering. Now we are going to see about the segmentation in operating systems. Segmentation. The process is divided into the segments, that is chunks that the program is divided into which are not necessarily all of the exact size are called the segments. Segmentation gives the user's view of the process which the paging does not provide. Third one, here the user's view is mapped to physical memory. Next one, types of segmentations in operating system. We have two types, that is virtual memory segmentation and simple segmentation. First one, virtual memory segmentation. Each process is divided into the number of segments, but the segmentation is not done all at once. This segmentation may or may not take place at the runtime of the program. Next one is simple segmentation. Each process is divided into the number of segments, all of which are loaded into the memory at the runtime, tough not necessarily contiguously. Next one, segmentation, memory management scheme that supports the user view of memory. That is, the program is the collection of segment. That is, the segment is a logical unit such as it contains main program, procedure, functions, methods, objects, local variables, global variables, common block, stack, symbol table, and the arrays. Next, we have that user view of the program. Here inside that logical addresses, we have the main program, symbolic table, stack, and the subroutines we have. Next slide is the logical view of the segmentations. It is in logical view we have that frame table. It shows that allocation of that table. Next one is segmentation hardware. Logical address consists of the two tuple segment table, that is maps the two-dimensional physical addresses. Each table entry has the segment number and the offset. Base contains the starting physical address where the segment reside in the memory. Second one is limit. It specifies the length of the segment. Next slide, segment table page register, that is STBR points to the segment table's location in the memory. Second point is segment table length register, that is STLR. It indicates the number of segments used by the program. Here segment number is defined as a S. Is legal if we have that S is greater than or greater than STLR, that is segment table length registers. Next we have the three types, that is relocation, sharing, and the allocation. In relocation we have that dynamic and by the segment table. Next one is sharing. In sharing we have the shared segments and the same segment number. Next one is allocation. In allocation we have that first fit or the worst fit. Next one is external fragmentation. Next we have the production. With each entry in the segment table associate validation bit is equal to 0. That is illegal segment. Next point is read or write or execute the privileges. Next point is production bit associated with the segments. Code sharing occurs at the segment level. Last one is since the segments vary in the length, memory allocation is the dynamic storage allocation problem. Next slide, we have the diagrammatic representation for the segmentation examples. Here we have that the CPU. CPU is connected to SND, that is segment table, and the dynamic allocation. Next segment table is connected to that limit and the base area. Here below that we have the segment table, and then here it goes under the condition whether it is yes or no, and finally it goes to, if the condition is yes, then it goes to the physical memory. Next one is segmentation with paging. The IBM OS or the 2.32-bit version is an operating system running on the top of the Intel 386 architecture. The 386 uses segmentation with the paging for the memory management. The maximum number of the segments per process is 16 KB and each segment can be as large as 4 gigabytes. The local address space of the process is divided into two partitions. The first partition consists of up to 8 KB segments that are private to that process. The second partition consists of up to 8 KB segments that are shared among all the processes. Thank you.